Hi, hello, welcome to the back on course of mechanical measurements. I am Nilambika N from Department of Collegiate and Technical Education. This is session 2 of unit 2, that is transducers and strain gauges. So before going to the second session, we shall go through whatever we have seen in the session 1. First we saw transducer. What is transducer? Transducer is a one which converts from one form of energy into another. So we saw some examples like microphone and loudspeaker, etc. Then we saw some of the characteristics of transducer such as good repeatability, good reliability, high sensitivity, low cost, etc. We saw some selectant factors to be considered for the selection of transducers such as nature of measurement to be made, and mechanical input characteristics such as linearity, mechanical hysteresis, creep, loading effect, transducer capability, economical consideration, etc. So we saw some sample questions in the session 1, and later we saw some multiple choice questions, so on. So next, here we are going to discuss the classification of transducer. So transducers are broadly classified into 4 groups. They are self-generating analog transducer, variable parameter analog transducer, digital transducer, and pulse generation transducer. Then we shall see what are transducer actuating mechanisms, and then we shall go through types of actuating mechanisms. Then we shall see some of the questions in this session that may be asked in end examinations. Then we shall summarize whatever we saw in this session. Then we shall conclude the session with test, that is multiple choice questions. I will be giving some questions to you. You need to write down the answers. So let's start. The topic here is classification of transducer. Here the transducers are classified into 4 categories as I said, and the number 1 we are seeing is self-generating analog transducer. What's happening in this type of transducer? In this type of transducer, our input parameter variation is converted into a continuous electrical signal, and for this conversion it does not require any external power source. For example, piezoelectric crystals. What's happening in piezoelectric crystals? When force is applied on a piezoelectric crystal, it is converted into a voltage. If you take photoelectric cell, here light energy is converted into a voltage. You can see the flow diagram here. See, in a self-generating analog transducer, it is taking a input quantity and it is converted into a analog electrical signal. The next classification is variable parameter analog transducer. What is happening in this type of transducer? In this type of transducer, an input parameter variation is converted into variation in the inductance, variation in the resistance, or variation in the capacitance. And this inductance later converted into the voltage or current. And for this conversion from inductance to the voltage, it needs external power source. For example, in LVDT transducer. So what's happening in LVDT transducer? The movement of the armature is converted into the change in the inductance. This change in the inductance in turn is converted into the voltage. So for this conversion, we are using in external power source. So you can see another examples are variable inductance transducer and capacitive transducer. If you see the flow diagram here, so variable analog parameter transducer So it is taking input quantity and it is also using the external power source. So by combination of these two we are getting a analog electrical signal. So in self-generating we doesn't require any external power source, but in variable parameter we are using external power source for conversion. So let's go to another classification, that is pulse or frequency generating transducer. In this type of transducer, the pulse generation rate is proportional to the input parameter variations. For example, frequency generating, frequency modulating and pulse counter transducer. The next classification is digital transducer. What's happening in digital transducer? In this type of transducer, it produces specially coded current or voltage for each input value it is sensed. Example like digital tachometer, shaft encoders and digital resolvers. If you take this shaft encoders, what here the rotation of the shaft is converted into the digital transducer. I hope you are clear with the 4 classification of transducers. And the next topic here we are going to see is a transducer actuating mechanisms. Transducer actuating mechanisms are these are elastic members in which it is pressure is converted into a displacement. So there are types of actuating mechanisms. Number 1, diaphragms. Number 2, Bourdon tubes. Number 3, bellows. Let's see one by one. First is diaphragm. What is diaphragm? Diaphragm is a thin circular plate which is fixed at the circumference. So whenever a pressure is applied on this diaphragm, it will get deflected. So you can see in this diagram. So this is a diaphragm where it is a thin circular plate fixed at the circumference. So whenever pressure is applied on the diaphragm, it gets deflected. So this deflection is proportional to the pressure applied on the diaphragm. So this is a flat diaphragm. If you can see, this is used to measure low pressure. If you want to use little higher pressure, we are using corrugated diaphragm. So it is also fixed at the circumference. So when a pressure is applied on it, it gets deflected. So we'll see another diaphragm called metallic or pressure capsule. It is used for larger deflections. Here what we are using 2 corrugated diaphragms. We are joined at back. At the end it is joined. So whenever is pressure applied on it, it shows the deflection. The next one is Bourdon tubes. So Bourdon tubes with the different types we can see here. So what is a Bourdon tube? Bourdon tube is a tube in which one end of the tube is fixed and another end is free. So when a fluid enters the tube, so this end will get deflected or it's try to straighten itself because of the pressure of the fluid inside the tube. So this deflection which gives the reading shows with how much pressure the fluid is entered. So this is a steel tube and another we have spiral tube and this is a twisted tube and this is a helical tube. So here also when a fluid enters, it straightens itself. So when it gets straightened, this deflection will give the pressure of the fluid inside the tube. And one more tube we have straight tube. Here also when a pressure enters, it gives deflection and this deflection will be giving the pressure of the fluid inside the tube. So as I said, the Bourdon tubes, one end of the tube is closed and other end is open to enter the fluid, and the fluid enters the tube. The fluid tube try to straighten itself because of the pressure of the fluid, and this makes the free end of the tube to move and it can be measured. So with the diaphragm we can easily measure the pressure of the fluid. So next one we have bellows. Bellows are thin walled tubes in the corrugated shape. So these are, you can see in the diagram, see these are thin walled, the shape of this is corrugated. So whenever the pressure, in this case the pressure will be either in compression or it will be in expansion. So whenever the pressure is applied on this bellows, it gives deflection. So this displacement or deflection will gives the pressure of the which is applied on the tube. So we will see some sample questions from this session. First one, write the classification of transducers with some examples. Then list out the 5 typical transducer actuating mechanisms. Third, briefly explain transducer actuating mechanisms. Then sketch the schematic diagram of transducer actuating mechanisms. So we shall summarize whatever we saw in this session. First we saw classification of transducer. Transducer are classified into 4 categories. The number 1 is self-generating transducer, variable parameter analog transducer, pulse generating transducer, and the last is digital transducer. In self-generating transducer, input parameter was converted into the output and continuous analog signal. So for this conversion, it does not require any external power. For example, piezoelectric crystal. And the second one we saw variable parameter analog transducer. Here the input variation is converted into the change in the resistance or change in the capacitance or change in the inductance. This change in the inductance, capacitance or resistance was converted into the voltage. For this conversion, it requires external power source. For example, in LVDT. Third we saw pulse generating transducer. Here pulse generation rate was proportional to the input parameter. Examples, frequency modulator. And the fourth is digital transducer. Here digital transducer produces specially coded voltage or current which is equal to the input discrete value input it is sensed. Example, shaft encoders. So these were the 4 classification of transducers. Next we saw transducer actuating mechanism. These are the elastic members. Whenever the pressure is applied on this actuating mechanism, it will be converted into the displacement. So next we saw types of actuating. Here we saw diaphragms, 3 types, bellows, and another one is Bourdon tubes. In diaphragm, what was happening? We saw flat diaphragm, corrugated diaphragm, straight diaphragm, metallic diaphragm. So in that diaphragm is a thin circular plate which is fixed at the end. Whenever is pressure applied on the diaphragm, it gets deflection. This deflection was proportional to the pressure applied on the diaphragm. So next we saw Bourdon tubes. Bourdon tubes are one in which one end of the tube is fixed, another end is free to move. Whenever fluid enters from one end, the another one will get straighten itself. This straightening or deflection will give the pressure of the fluid which is inside the tube. So we saw types of Bourdon tubes like spiral, twisted, helical and seed tube types of Bourdon tube. Next we saw bellows. Bellows are the they were the in corrugated diaphragm of corrugated shapes. Here the pressure applied is in the compression or deflection. This pressure is converted into the displacement. So we saw some sample questions from this session, and the next we shall take up the test. Okay, I'll be giving some multiple choice questions for you. Then you need to write down the answer. The first question is, in transducer actuating mechanism, pressure is converted into the option A voltage, B current, C force, D displacement. Write down the answer. What's happening in transducer actuating mechanism? Pressure is converted into The solution is D. Displacement. In transducer actuating mechanism, the pressure is converted into the displacement. Second question. In dash, two corrugated diaphragms are joined back to back at their edges. Option A bellows, option B corrugated diaphragm, option C metallic capsule, option D Bourdon tube. Write down the answer. In which kind of diaphragm the two corrugated diaphragms are joined back to back at their edges? The solution is C. Metallic capsule. In metallic capsule, two corrugated diaphragms are joined back to back at their edges. We'll go to next question. Dash are thin walled tubes in corrugated shape. Okay. Option A bellows, option B corrugated diaphragm, option C metallic capsule, option D Bourdon tube. Write down the answer. The solution is option A bellows. Bellows are thin walled tubes in corrugated shape. We'll go to next question. Mark true or false. Variable parameter analog transducer requires an electrical source of power for conversion. Is it true or false? The solution is option A true. Yeah. In variable parameter analog, it requires an external source of power for the conversion. The next question is mark true or false. Self-generating type of transducer requires an external power source for conversion. Your options are option A true, option B false. Write down the answer. The solution is P false. Self-generating transducer does not require any external power source for the conversion. Okay, it does not require any power. I would like to end up this session with a quote from Benjamin Franklin. He says, "An investment in knowledge pays the best interest." So let us acquire more of the knowledge. Thank you.